Okay, I was asked to go ahead and walk through this problem from the My Math Lab homework. This was 4.1.57. And they want us to go ahead and find the critical points or domain endpoints where the derivative is undefined. And for our original function here, the domain is all real numbers. So we don't have to worry about domain endpoints on this question because there aren't any. When I went ahead and I did graph the function in Desmos, and just noting that the function continues on unremarkably outside of what is graphed here. But what's of interest in our graph here is that around what looks to be x equals 0, it looks like the derivative is undefined. However, we must confirm this. And there also does appear to be a horizontal tangent line. At a point that's a little bit less than 0. So there's two critical points here. One of them is where the derivative is undefined. The other one looks like it's where the derivative is equal to 0. So now let's go back and find the derivative. And I'm going to do one quick thing though before I take the derivative. I'm going to go ahead and I'm going to multiply this out, because if I multiply this out now, I don't have to worry about using the product rule when I take the derivative. So taking the derivative, I get 7/5 x to the 2/5 power. And that's going to be plus 2 times 2/5 x to the negative 3/5 power. Clean that up a little bit. And just a quick thing that we should remind ourselves about is that x to the negative 3/5 could be written as 1 over x to the 3/5. And it's this that lets us know that at x equals 0, the derivative is undefined. So that's what it looked like on the graph, but now we've gone ahead and confirmed that. So in terms of what the question is asking here, we would go ahead and fill that in at x is equal to 0. Now, from the question that's displayed here, we're done. But as long as I'm here, let's go ahead and see what that other point is where the tangent line is going to be 0. Now, not a big fan of dealing with fractions. So let's multiply both sides by 5. And the next thing I'm going to do, and hopefully you remember this from college algebra pre-calc, I've got two terms in here I'm going to go ahead and factor out the lowest power of x. And when we factor out the lowest power of x, that leaves us with that. And if you wanted to check that when you multiply by the same base, you'd add exponents. 1 plus negative 3/5 takes us back to the 2/5. So that is going to work out for us. And now by the zero product rule, we know that either that are equal to 0, but we already kind of ruled out that case. So this means that 7x plus 4 has to equal 0. That means 7x is equal to negative 4. That means that x is equal to negative 4/7. And looking back at the picture, that certainly looks reasonable there. And on each of the, and each of these points, what we have here is we have local minimums and local maximums. So at our critical point that they were asking about, we've got a local minimum of 0 at x equals 0. And how do I know for certain that that's equal to 0? Well, if we go back to the original function and plug in 0, then our first factor there is 0. And if we wanted to figure out exactly what our local maximum is, we would go ahead and plug in negative 4/7. And we'd find out what the value is, what the y value is there of our function. That's arithmetic, and the video's long enough, so I'll leave that one for you guys to go ahead and figure out.